I would like everyone to mute their speakers. अब म्यूट रखें और अगर किसी ने कोई बात करनी हो तो raise your hand. So we can start. In fact, today is a workshop on intelligent manufacturing. So, Assalamu alaikum, Hazreen, and we start our discussion today, and we'll go slide by slide. And this is really from an international coalition on international manufacturing that we have entered into Pakistan with China. Or we are on the Institution of Engineers Pakistan side, and today is Saturday, January 15, 2022, and we will have a session here and see uh, what is involved in intelligent manufacturing. And in intelligent manufacturing, as we just discussed a bit earlier, that it's no rocket science. Things are coming, things are there, and we all we are used to some extent about smart working. And smart working, we all have smartphones with us, the internet with us, and laptops with us, and so it's not really a completely a new situation. We are to some extent familiar with all this, but we need to see how we can introduce these instruments, these smart instruments, uh, into our manufacturing. So we will go slide by slide, and on this slide, as you see, uh, the Institution of Pakistan, Engineers Pakistan, has entered into a coalition, an international coalition on intelligent manufacturing with Chinese Mechanical Engineering Society, and we are a founder member, co-founder member of this effort, and I thought we have a workshop among ourselves first, and then we enter into an international workshop at a later date. Uh, this, in fact, session, we go slide by slide, and we have these five issues to go on with. First is to introduce Industry 4.0, 4.0 they call it. And Industry in 4. What is really mean Industry 4.0? And it involves artificial intelligence and smart manufacturing and intelligent manufacturing. So these terminologies are basically these are some loose terms around, and there are some little bit of differences as we use these terms. So we will go through in this chapter 1. Then next, we will study how China has conducted a structural transformation as far as manufacturing is concerned. It has taken a lead, and it has utilized its population, and it has raised the income level to quite an extent by the use of intelligent manufacturing. Uh, so, in the next stage, number 3, we study how developing countries like Pakistan, or Pakistan still calls itself a developing country, although it's quite up on the way, and I think we should stop using the word developing countries. We are all quite developed in this respect, but there are many countries which are really lagging behind, many African countries and other countries, and we need to see how we get on with intelligent manufacturing, and side by side, we have to ensure poverty reduction, because intelligent manufacturing has some adverse effects on loss of jobs and on poverty, and we have to see that we do something about that as well. So on the chapter 4, we will study the present level of small and medium enterprises. That is called SMEs in Pakistan. We have had a survey on SMEs in Pakistan, and we'll see how intelligent manufacturing can be successfully introduced into small manufacturing enterprises. Uh, 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 in, in some large manufacturing enterprises in Pakistan, intelligent manufacturing is already in practice to some extent. But there is a great gap uh, between the small manufacturing enterprises and medium enterprises compared to the big ones. And number five, we will see what step-by-step process is there. If any manufacturing unit wants to uh, get into intelligent manufacturing practice, what are the steps available? What can they do really? So to start with, let's me go to the next slide, and we'll talk about this fourth industrial revolution. I mean, there have been three industrial revolutions already there. Uh, really, this first revolution, second revolution, third revolution, and now fourth revolution, we are really talking of European history, really, because the first industrial revolution took place in Europe, the second also in Europe, but in countries like Pakistan, we did have these revolutions in gaps or in stages. They have all been mixed up. So part of our industries here in Pakistan, they are already in the level 4, and some of them are level 3, and some are in level 2, and many very small units, maybe they don't have any level to work talking of. So fourth industrial revolution really is a mixed up of physical work, digital work, and human effort. So it is all connected together. It's really integration. And how this integration has taken place, it's really due to artificial intelligence, robotics, and Internet of Things, that is called IoT, Internet of Things. We'll talk about all these terms, and we will see what exactly they mean, because these terms sometimes they intermingle with each other, and we use them in a very mixed way. 3D printing and genetic engineering and quantum computing and other technologies. Industry 4.0 it is called, um, because in future workshops when we participate and on the international level, there are workshops that are going to be offered by Chinese Mechanical Engineering Society. They will be mostly talking in terms of Industry 4.0. So Industry 4.0 really includes Internet of Things, IoT that is called, the industrial Internet of Things. This is a bit more advanced, more applied form of IoT to manufacturing really. And then cyber physics system, CPS, and smart manufacturing and smart factories, cloud computing and cognitive computing and artificial intelligence. So one by one, we will see these terms are used, and what do they mean really, and how overlapping is there among these terms. So what is really IoT? That is really called as it is called the Internet of Things. In fact, this is a network of physical objects or devices, we call it, like temperature measurement devices, thermostat, or speed measurement devices, any other sensors. Sensors are fitted in the manufacturing equipment, and sensors are fitted, and cameras are fitted, and all these they are integrated together, and they take the data and uh, transfer it to software, and where simulations are done, and this is all called IoT, or Internet of Things. Now, for example, network of connected objects, they they are they are able to collect and exchange data in real time, and they're because of these embedded sensors. These embedded sensors are thermostats, and car lights, maybe refrigerators, their appliances, and connected to IoT. They are data generators, really. These sensors pick up data, speed, acceleration, shake time, and other kinds of data, temperature, pressure, maybe. And this data is transformed, is communicated through internet to softwares and big data collection and analysis, analytics we call it. So the industrial Internet of Things, IIoT, it is brief, and it is really an extension of IoT. So it is application into industrial sectors. Next, we really want to distinguish between the various terms that are used. A term is used that is CPS, cyber physical system, and in fact, cyber physical system uh, is a computer-based analytical system, a computer-based algorithms really, which controls and monitor physical mechanisms. Physical mechanism like turning of a lathe, or moving of a vehicle, or these fighting equipment, or maybe entry devices, automatic doors, or whatever they are. So this this physical systems, physical devices, if when they are connected through internet, then we call it cyber physical system. Example is like smart grid, autonomous automobile systems, medical monitoring and industrial control systems, and robotics, and automatic pilot avionics. Now, these are examples, and these examples are cyber physical systems. Uh, if our manufacturing has to enter into intelligent manufacturing, then we need to build into our operations, our system, the cyber physical system. The, the CPS is similar to embedded systems. So sometimes this the word is used embedded system. The embedded systems is also something like CPS. An embedded system uh, has uh, has a microcomputer uh, built into the system, and which picks up the data from the sensors and makes analytics, and so that we can monitor and control the working of the system. And while CPS, in fact, focuses more on the link between the computational side with the physical side. And CPS is also similar to Internet of Things, that is IoT. So these are two terms, CPS and IoT. They are quite similar, and they're loosely interrelated to each other. But CPS has a higher computation form and a coordination between physical and computational elements than IoT. These are small differences on the terms that are used, and we will be using them quite commonly. Now, what is cloud computing? Some computing is done right on the machine level. Some computing is done through internet into a control room of that machine hall or a production hall. But there is a bigger available computer system that is called cloud computing. Cloud computing is like you get yourself registered to the available greater, bigger computer system, and that offers you storage and computing. Uh, so your computation and your storage is done by an outside agency, and you don't really have to have an active management or of the same system. That is a facility available to us, and that facility can be availed on your internet that you are working on laptop, or you are working on your mobile, or your system of IoT that you have established in your manufacturing unit. So this is really an application-based software infrastructure. It stores data, and it stores data in the remote servers really. So you don't really store data on your own laptop, but the data goes into a server, and that is a bigger capacity, and its computation capacity, speed is more, and you can access, you can draw your data from it, and you can add some data. Uh, it goes related to your specified use. Examples of cloud computing are Google Cloud, and public cloud services offered by Google, Amazon Web Services, Microsoft Azure, and Google Drive, iCloud, and Dropbox. You must be already familiar with these Dropboxes, because when a file is quite heavy and you need to transfer it to another place, then you must be using the Google Drive facility, which is available. Then there is another term which is used as cognitive computing. And cognitive computing is very similar to artificial intelligence. And cognitive computing is really a system of hardware and software that is available, and that, in fact, mimics, it copies uh, human brain. And when it does mimicry work, that is called a cognitive computing. And there is a slight difference between artificial intelligence and cognitive computing, that artificial intelligence, that is as AI, uh, in fact, works on the level of human thinking, and its ability to solve complex problems. Whereas whereas cognitive computing really is mimicry. Mimicry means uh, copying the voice and and regenerating the voice like human being. You talk into it like you have Amazon's Alexa and Apple Siri. They are these are the cognitive computing facilities. You must be familiar with this Siri or Alexa, and you talk to the computer, and computer gives you the reply back in human voice. So it's a voice generated uh, by the computer. Sometimes we use this term smart manufacturing. And smart manufacturing, in fact, is digitized method. And it has smart manufacturing is digital solutions. And it really has productivity and data analytics and automation. So uh, with help of these smart tools, if you apply these tools to manufacturing, and we call it smart manufacturing. And smart manufacturing has three stages, you can call it, or three elements, you could call it, uh, three systems, you could call it. One is an enabling system, that is digital solutions such as IoT and AI, that is intelligent artificial intelligence. And second part is improvement drivers, which provide you connectivity from a computer to another computer, from a device to a service, and that is connectivity, analytics, and automation. So these three functions are uh, are grouped into improvement drivers. Then we have a third stage, which is called final outcomes. That is, outcomes means really the the the, the drives that are uh, that are told to you or communicated to you uh, regarding operations and regarding various uh, targets that you set in for your manufacturing system. Then Industry 4.0, the term 4.0, as we have already discussed and already talked about, is it refers to the fourth industrial revolution, and that is a continuation of earlier revolutions like Revolution 1 and 2 and 3. Now it is 4. We'll talk about it in, uh, in detail, and sometimes Industry 4.0 and smart manufacturing are used in a loose way, meaning same. What is the really uh, the the process from digital system to smart system and finally to intelligent manufacturing? Digital system of manufacturing was the first stage, and digital system of manufacturing really means using computers in support of machines and operators. And smart manufacturing is the second stage, a stage which comes after digital manufacturing. And in this stage, we use networks. So, networking means connectivity, connection from one machine to a central control unit, or maybe one central control unit to big data and servers. So this is the second stage, and this is called smart manufacturing. The third stage, after smart manufacturing, the third stage is IM, that is intelligent manufacturing. Intelligent manufacturing, in fact, has an additional ability, and that is a machine self-learning. The machine intelligence or machine learns itself from the experiences. Machine really is the you can say it is a when there is the autopilot in the plane. The autopilot in the plane is a self-learning uh, machine really, and that autopilot uses data, uses experiences, and makes decisions. This uh, automatic system of making decisions by the machine is called intelligent manufacturing, and it all it includes big data, it includes CPS, includes cloud computing, and all this is integrated together, so that manufacturing can be facilitated and can be done errorless, zero error manufacturing is the target, in fact. So this is how really we go ahead and introduce in our manufacturing uh, the smart systems and the digital systems, and then intelligent manufacturing. Now, Pakistan is entering into it, and we need to have a look. We really need to have a look at how Chinese have developed themselves up, and how Chinese have entered into the revolution 4.0 stage. China, in fact, have taken a big leap jump. Uh, it has uh, it has used a system which is called comparative advantage following, CAF. It is called CAF. Comparative advantage following was really a self examination of its own system, that at what are the advantages, where do they have the advantage, where they can have a market edge. And they found that their marketing edge was really the cheap labor that China had. Abundant labor in the countryside, in the towns and in cities, abundant cheap labor that was available to them was a comparative advantage for them. So they really make maximum use of the cheap labor they had with them. And as you have seen that China was heavily public oriented. Their manufacturing facilities were really in the big public owned plants and manufacturing plants. So they stepped down to small local plants. And this was, in fact, a two-pronged reform system they undertook to themselves, that they provide temporary protection and subsidy to the traditional public-owned bodies. At the same time, they make new viable sectors available, which had comparative advantage for themselves, and in form of the established town village enterprises. So they went into small towns and villages and established small facilities, so that they can take advantage of the cheap labor with them. So this has been really a marketing edge which China has taken advantage of. So the the share the the share in GDP that that was going into uh, primary sector, or the big public owned sector, uh, was reduced, and it was spread into or diffused into secondary sector, or even into the tertiary sector. So by doing this, uh, they employed a lot of cheap labor, and by doing this, they spread out, and by doing this, they could sell their products at a cheaper rate in the international market. So town and village enterprises, TVS, they call it. These town village enterprises, they these are like SMEs in Pakistan, like small and medium enterprises in Pakistan. But they called it town village enterprise. and they provided opportunities for the rural people to work and increase their income levels. So government provided a lot of facilitation for the town village enterprises, and this is how they improved the employability of the rural areas. By going right down to the tertiary level, that is local levels, town and village levels, they uh, they they upgraded the living standards of a large number of their workers in not only in rural areas but also urban areas as well. And with this comparative advantage following strategy, the labor-intensive industries developed very rapidly, which in turn created new working opportunities. So the state-owned, public-owned enterprises were downsized, and town village enterprises was upgraded, and as a result, a lot of people raised their income levels. Even the rural and small town people could earn uh, quite handsome amounts, and this is how Chinese has taken advantage of. On the one hand, an advantage, a marketing edge in the world share of economy, and they have also raised the income level of their rural and small town people. So I can show you a graph which really, if you look at this graph, it starts from 1978 to 2008, and on the vertical axis, you see the percentage share of GDP in various sectors. Uh, red is the primary industry, and green is the secondary industry, and this gray is tertiary industry. And as you see, as the years uh, went by, the primary industrial share goes down, and the secondary industry is more or less stays the same, and tertiary industry share goes up. So this has been a model, and this is a transformation that China has undertaken. And now we can follow this example. In fact, in Pakistan, there are 60-70% people workforce. They live in rural areas and small town areas, and they are not being the, that efficiently utilized. So mm, if now we have the availability because the internet is available, the, the communication facilities are available. So this disadvantage of the distance uh, with the rural areas, uh, the disadvantage is no more there. So in uh, today's interconnected world, uh, distance really doesn't mean much. So we can make use of people who are living in far-flung areas, small towns and villages, and bring them, integrated them into our manufacturing and take advantage of them. Now, this is a bar chart, really, and it goes from 2001 to 2007. These bars you see, and the various sectoral uh, progress. Uh, First sector is green, computers and office equipment. The second sector is pharmaceutical, and the third sector is electronic and telecommunication equipment. They really concentrated on these three sectors because these the three sectors were the one in which China could compete easily in the world market. And these three sectors, I say that they have been growing. Uh, Fastest growth is computers and office equipment, and second sector is pharmaceutical, and the third sector is electronic and telecommunication equipment. As a result of this TVE's strategy, as you see, China's population has moved. It's moved from the western and mid-western areas to eastern areas. From this map on the left, you can see how the population movement has taken place. And on the right hand side, as you see, the migration from the central region to coastal region. And in this next diagram, this is also a bar chart, and it gives you percentage, proportional share of number of employees in manufacturing and different trades of manufacturing. Really. And as you see, the tallest bar is communication equipment. So today, if you look at China's manufacturing, you will find that maximum number of employees are employed in the communication equipment, manufacturing of communication equipment. The second highest employer sector is transport equipment. Then comes textile. Then comes mechanical, robotics. So this is how how the disbursement of um, employees, workers in various sectors of manufacturing is in China is depicted, and you see that uh, this has been really due to the fact that connectivity has reduced the distances, and I mean, any any enterprise, any manufacturing unit anywhere in China can be connected to large cities, and they can do trading with them, manufacturing, transporting, and system is working because of intelligent manufacturing coming into it. As a result, you see, as a result, this chart shows uh, the income per capita of urban and rural households. As you see, there is a tremendous increase with green, there's a red line, there is a tremendous increase in the household income in the period from 1978 to 2008. Red line is urban and green line is rural. So this is how really China has accomplished its task of raising the income level of the households, and this has been really due to the fact that they have introduced productivity in their systems and intelligent manufacturing in their systems. Now, let me go down to the next chapter, and let me see this industry 4.0 really integrates or it amalgamates the physical and the human worlds together, and it incorporates uh, artificial intelligence, and robotics and Internet of Things, 3D printing, genetic engineering, quantum computing, and other technologies. So Industry 4.0 is really a collective force, and we can make use of it. And, products like GPS system is also a part of intelligent manufacturing. GPS system really is the fastest route location, destination location, and this capability of these intelligent systems that they are available today, uh, we can make much use of and improve the quantum of a product of a manufacture as well as the quality of the manufacture. But it has an adverse effect as well. We have to safeguard uh, uh, from the adverse effect of the intelligent manufacturing. Let me go to the next slide. Intelligent manufacturing industry 4.0, really what it does, uh, it, uh, it loses jobs for people. A lot of people will lose jobs. This is the adverse effect of all this. You see on this figure, heads are being cut by this machine. Heads are cut by the machine. It really indicates that people will lose jobs. It, uh, it on the face of it, it looks as if it is terrible and things are going to be very bad. Uh, but it's not really. It's not really losing job, but it is transferring of one kind of job to another kind of job. So it's really shifting of the workforce, of shifting of the habits or the kind of jobs they are used to. So we need to be careful, and we need to look after and keep our people employed in such a manner that these adverse effects are mitigated. Now, we can't resist really onset of Industry 4.0. It is coming. It is inevitable. You can't resist it really. And some of us are already into it. And so Industry 4.0, and it the brings some negative effects. Apparently, they can call them negative effects, but some of our industries are already there, very much near Industry 4.0, and the bulk of industries are lagging way behind, but they are also coming forward. And they have a task now to make serious efforts. On one hand, of bulk of industries to upgrade themselves, enter into Industry 4.0 and take advantage of its potentials and its power. And on the other hand, uh, uh, look after the adverse impact on humanity, economy, and on businesses, and transform the workforce into usable forms. So this we can do this because mm, this is the task really. We have to um, some manual skills are no more required. Then the skills which are required, we have to bring our people uh, towards them. Now, even in the previous industrial revolutions, the industrial revolutions which took place in the past, especially in Europe, uh, the same adverse effects have been there. People lost their jobs, a great number of them, and this has happened in Europe, and this has happened in the first revolution, and this has happened in the second one, the third one. Now, the fourth one will also have the same effect. But uh, it's really it's loss of jobs of one kind, but a shift of jobs towards the other kind. So we need to see uh, how we can do that, how we can manage, and this has to be managed at the national level really, and people have be uh, to be trained, and their skills have to be developed into those jobs which are uh, now available, and so that their income level is not cut down, or it is rather increased. As we have seen the example of China, where the income level of the ordinary household, even in the rural areas, has increased to larger extent. Such as I can give you an example of this donkey driver. This donkey driver has a smart mobile with him on his hand. So he can maybe do the same work transporting luggage equipment, but in a more efficient way, with taking orders on his mobile, and telling people where is he, and routing his services in a better way. So really, it's a shift from one kind of or system of work or habit of work to another kind of or a habit of work. It is coming, and people are getting used to it. As you see, most of our people, even the sweepers, the donkey drivers, and uh, laborers, they all have uh, mobiles with them. Mobile is so common. Even domestic servants have mobiles with them. So it's the right time that we may make use of the mobiles, and uh, facilitate our daily routine of work in such a way that if the productivity increases, then naturally the income level. Same applies to a work uh, situation in a manufacturing uh, floor level. Uh, Instead of welding, uh, manual welding with your hand, we have a robot doing the same work, and a robot is the controlled, monitored with a mobile in your hand. So one type of work is being shifted to another type of work. So we must understand that the movement towards intelligent manufacturing really means shifting of your habit, and learning. Uh, it's a learning of the intelligent systems that they are available with you, and they were not available to you in the past.
जैसे माइक्रोवेव में पहले इसमें कैसे गर्म हो सकती है
On the right, as you see, this shift of the workforce, as you see these bars, uh, 0, -10, -20, -30 is on the left hand side, and plus is on the right hand side. And these negative bars are manual manufacturing and transportation, public administration. The jobs are going to be reduced. And on the positive side, as you see, education, hospitality, communications, and scientific and technical and IT, OT jobs are going to be increased. So the workforce, the dispersion or distribution of workforce is going to be different. And when this happens, uh, artificial intelligence uh, can be used for looking after the overall aspects of the society, like food security, like health, energy access, and education access. Education access is much more these days using artificial intelligence than it was previously in the past. I mean, the rural areas, uh, education uh, was limited, the health facilities were limited, but now with the help of artificial intelligence and connectivity, this handicap is no more there. Poverty, when we talk of poverty, in fact, poverty has two levels: individual poverty and system poverty. Individual poverty is poverty is the individual level. One person is not being able to earn enough to make his basic needs like food, health, shelter, and education. We call him a poor person. Now, in order that the poor person does not remain a poor person, then he uh, comes out of the poverty level and he is able to avail all these facilities. He has to put himself up and he has to change the skill set to another skill set. But there is another level of poverty reduction that is on the system level. The system, in fact, if the whole system uh, is not able to, the overall system is not able to uh, provide education, food, shelter to the communities as a whole, then there is that is called a failure of the system. So that is the poverty on the system level is much bigger and much devastating than the poverty on the individual level. So we see that the artificial intelligence today can cater for poverty reduction on the system level. Artificial intelligence, in fact, comes to rescue, and it has the ability to reduce poverty on the system level. If we go along with the Sustainable Development Goals of the United Nations, follow them. There are 17 goals, and if we follow them, we can attend to the reduction of poverty at the system level, and that is where artificial intelligence can help us out really, and it helps us because of the ability to collect poverty data, map poverty data, revolutionize agricultural, education, and financial sector. So, mm, apparently, intelligent manufacturing, which comes and hits the brings adverse effect to the to the people, and on the other hand, the use of the same gadgets and instruments at the facilities of the intelligent manufacturing, we can apply them on the poverty reduction on the system level. The balance has to be really taken up. Many people are connected together now. In this industry 4.0 stage, people are connected together. I mean, we don't realize the power of it, how connectivity can really do uh, great uh, jobs done on the system level, uh, simply because people are connected, people are well informed, they are aware, they have access to education, they have access to health, they have mobility, they know each other through their mobiles, through their internet, and this connectivity was not there in the past. Now, Industry 4.0 has the potential really of bringing people together and helping each other in this way. So this is a great asset. Poverty mapping is also done by these instruments that we have today available with us. Poverty mapping on the countryside, on a national level, and mitigation of poverty by mapping, by livelihoods, by education access, and so we need to concentrate on using these smart facilities which are available to us today. They were not available to us in the years that have gone by. Artificial intelligence helps us in transforming our farming, our agriculture, and productivity on the farms. And when the productivity on the farms increases, naturally there is a direct relation with reduction of poverty. Similarly, artificial uh, neural networks can be used for trading and for financial uh, transactions. And I mean, this, so these smart systems that are available to us can really uh, help us in mitigating the apparent job uh, losses that we foresee in the coming years to come when we get into intelligent manufacturing. Marketing uh, is also, this is much more easy to do marketing these days using these instruments, smart instruments, and this is how Chinese uh, have been able uh, to spread their products all over, almost all over the world, and using uh, these internet and smart technologies that are available today that were never available in the past. Drones, drones are also an example of these smart technologies that are available today, and use of drones can be very useful as well. The use of drones, uh, they take you to places where physically, humanly, you cannot be there and drones can fetch you data and photographs and surveys and mapping. So these intelligent instruments that we have today available with us uh, can help us a lot in organizing our effort, and that will affect the workability, the profitability, and we have to use uh, these systems, and we transform our economy into an intelligent manufacturing economy. इकबाल once said, दिल के लिए बहुत मशीनों की हुकूमत एहसास मरम्मत को कुचल देते हैं आलात. Why Iqbal was against machines? Iqbal was against machines because machines were working against the people of the subcontinent of India in those days. Because machines were there in the Europe, and Europeans were manufacturing, and they were drying out the raw materials from the undeveloped world, take them there, and then sell their products back to us. And this way, they were really uh, mm, spreading poverty into these countries, such as the subcontinent of India. And that is why uh, Iqbal really raised his voice that machines machines are working against us. But today, the situation is completely different. Today, uh, the same machines can be useful to us because we are the users of the machines, and we can use the machines for the for the poverty reduction and for the sake of bringing livelihood to our common man around in the rural areas as well as in the urban areas. So machines, machines are for sake of the people. They should be of the people, by the people, and for the people. And smart machines, really, smart machines, which can help us a lot. Next chapter we come into, we have a survey of small to medium enterprises in Pakistan, and see what what do we call a small and medium enterprise? Definition. So small and medium enterprise is one which has a paid-up capital of up to 25 billion rupees, and it yearly deals up to rupees 250 billion. Now, when we come to see how many small and medium enterprises are there in Pakistan, we'll be surprised that they are 90% of all enterprises in Pakistan are into this category of small to medium enterprises. So it's really SMEs, small to medium enterprises, that should be our target. And that is the place really where about 80% of our non-agricultural labor force is employed. And that is the place where the share in the annual GDP is approximately 40%. So it's a very important sector. And this is the sector which is a dry sector. That means uh, does not really utilize the capabilities of the intelligent manufacturing to that extent. The big industries, of course, they 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 are on the front lines, and they have utilized uh, the intelligent manufacturing techniques to some extent. But this is the small to medium enterprises which are lagging behind, and they are not really using uh, the facilities, the the technologies of the intelligent manufacturing to that extent, that level. And mm, uh, there is another problem with small, medium enterprises that they are constrained by financial and other resources. So the mobility of financial resources is a, is another issue which has to be tackled, and I think there also artificial intelligence can also be used for making capital available to these small to medium industries. So what is required there really? What is required there as an outcome of the survey is that they required uh, availability of financial instruments and upgrading of their technologies, upgrading of their marketing availabilities, and training of the of the of the human resource there. We have conducted various survey and seen the extent to which intelligent manufacturing instruments are being used in small to medium industries in Pakistan, and a sample survey really, and we see that the deficiencies are there in technologies like use of big data, use of cyber physical systems, and Internet of Things, and interoperability and the performance of this small to medium-sized enterprises that they could have utilized. The questionnaire was developed and distributed randomly to places like Karachi, Lahore, Peshawar, Islamabad, Gujarat, and Sialkot. And the questionnaires were received, the filled up questionnaires were received, and multiple regression techniques, SPSS, were employed, and uh, relationships were analyzed that what are the areas which are deficient and what are the areas which have a potential of utilization. So in this chart, as you see, this is a manufacturing unit, and mm, they need to know, the small to medium enterprise need to understand really uh, what they are, what they are supposed to do, and what are their capabilities, what are the deficiencies, and how, to what extent they can make use of networking that could be available to them. And um, it's really um, IoT and IT which can come and which can help them to a large extent. Major shortcomings uh, in SMEs in Pakistan are ineffective business information structure, lack of strategic planning, and lack of human capital required in the modern era business. Now, such deficiencies uh, need to be tracked, need to be removed, and mm, much good work can be done by the use of the instruments, the smart instruments that are available to us today. Such efficiencies can be resolved by the small to medium enterprises and upgraded and uplifted by the use of these digital technologies that are available to us. Uh, the major targets for SMEs in Pakistan, as seen from the survey, is uh, digitization and availability of big data, use of IoT, and interoperability and CPS. And so this is a very major sector, and in this major sector, uh, I think this use of these modern techniques and smart systems can help them a lot. So this is the result of this, this survey. So the interesting relationship was derived, such as 1% increase in the use of big data could improve the business performance by 30.7%. 1% use, 1% increase in CPS use could lead to 31.4% increase in business performance. And the 1% increase in the use of IoT could result in 17% increase in the business performance. 1% increase in the interoperability could reflect 28.3% increase in the business performance. This is the cause and effect relationship analysis. Using IoT uh, means putting sensors and connectivity and data control, use of big data, system use uh, of analytics that are available today. They can improve their performance to a large extent. It's really up to the managers, that the use of these capabilities and smart instruments in their work floor level, and this is how they can make good use of it. Well, let me see how we can stage by stage introduce these abilities, these smart technologies into our system. And there are a set of toolkits available these days. And toolkits, a set of toolkits at various levels, they have to be introduced step by step in such a way that easy assimilation of the practices at the floor can be done. Let us go through what are the toolkits available to us that can be introduced in the enterprises in Pakistan. How do you really make a factory smart factory? There are 8 steps, 9 steps of building a perfect smart factory. We are talking of SMEs. Number one is invest in IT and IoT. So, this is number one. This is the start point. Actually. Number two is develop wireless connections. Number three is use of collaboration technology. Number four is make sure that IoT and IT departments converge with each other. Number five, train and introduce new required skill sets. Number six, invest in data management. Number seven is digital mindset and soft skills. Number eight is integrate marketing, finance, and trading with manufacturing. Number nine, be open to change. It's easy to say, hard to get. Or be open to change. Lethargy and inertia uh, really is cutting our way, and our managers really need to be open to change. This journey from conventional manufacturing to intelligent manufacturing in a nutshell looks like this. Level number one is the data integration analytics. Level number two is advanced analytics and enterprise integration. Level number three is predictive and prescriptive capability. Level number four is customer inclusive and symbiotics. So, in the first stage, blend data to detect unseen equipment and online problems and single pane of glass operational view. On the second level, minimize losses by predicting quality problems and preventive condition-based maintenance. And at the last level is the full scale cycle, life cycle production insights, optimizing processes and equipment and people. So as a smart factory, you see that machines, self-learning machines are doing the job of manual labor, and these machines are connected to your workstation, and you are really working on your laptops or on mobile, and controlling the entire manufacturing uh, intelligently through your laptops and through your mobiles. First set of toolkits. The first set of toolkits really goes at the product level and at the process level. At the product level, uh, we have these incorporation of sensors and actuators integration. D is communication and connectivity. C is functionality and data storage and information exchange. D is monitoring. E is product related IT services, and F is business modules. And at process level, A is data processing, B is machine to machine learning, communication, C is company wide networking with production, and ICT infrastructure, and man machine interfaces that are called HMIs. And F is efficiency with small batches. Most fundamental toolkit in this respect is ICT, and ICT data integrated with technologies like CAD and CAM and 3D printing. These are the vital elements to start with. And then we come to making business models like charts and brainstorming, employee education, and all the training and all this needs to be integrated. There are toolkits available which, if you introduce these toolkits into your manufacturing, then these systems can be integrated together. These toolkits are available, in fact, and I can show you the tables that what are these toolkits, and there is there are a set of levels. You go step by step, introduce these toolkits, and go on the road of intelligent manufacturing in your small to medium size enterprises. And first toolkit is called MFTs, which is manufacturing fabrication tools. And these are used for manufacturing, and they involve human labor. And the human labor, to, to facilitate the working of the human labor, you have manufacturing and fabrication tools. And they are like lathes and casting and carpentry and mill welding, etc. And as soon as we make use of them in manufacturing and production. Second set of toolkits are DSTs. DSTs are really design and simulation tools. And these design and simulation tools are deployed during the design phase and simulating uh, production. And process simulation in CAD and G codes and 3D printing. These are the aspects. Then the third stage is RATs. RATs are really robotics and automation tools. This is the third stage of use of these toolkits. And these toolkits can perform repetitive work and automated and modular work. And they are used in material handling, conveyor systems, belts, scanners, and printers, etc. Then the fourth set of toolkits are CSTs. CSTs are sensors and connectivity tools. These sensors and connectivity tools really uh, convert outputs to readable format, outputs of the sensor to readable format, to further communication to data centers. And what is involved there are microcontrollers, boards, sensors, actuators, Wi-Fi, M2M, and digital readouts mobile units. Next set of tools are called CSTs. So these CSTs are really cloud storage tools, and uh, they provide you a storage space, large source storage space for your data. And data is used for decision making, and data is used for interpretation of the trend and fault diagnostics. So that is the stage you need to get into cloud computing. And cloud computing, as we have talked before, is available on Google Drive, Microsoft MS, Azure, and external hard optical drives, etc. Then there are DATs. DATs are data analytical tools. And these data analytical tools really support data analytics. And there is another set of toolkits. These are called BMTs, and BMTs are really business management tools, and they support the development of business models, and awareness in organization culture, collaboration, attending workshops, reading reports, marketing, and employee relations, and all that operational and management that can be integrated to manufacturing, and this is how uh, various stages are covered for getting into intelligent manufacturing. Set one now to some details. Uh, FMTs are fabrication manufacturing tools, and DATs are data analytic tools, and DSTs are design simulation tools. So these are toolkits. We introduce our manufacturing step by step, stage by stage, and to follow a process of transformation from conventional system of manufacturing to intelligent system of manufacturing. This is the second set of tools that again DATs here, DSTs here, and CSTs. There are cost simulation tools. The next set of toolkits are robotics and automation tools. Still further, we get into uh, cloud computing, sensors, and connectivity tools. This is the way forward, really, for an SMEs to get into intelligent manufacturing. Cloud storage tools we have talked about, and management tools. They are really making use of the big data analytics and large kind of storage that is done by cloud computing. And another set of tools are called BMTs, the business management tools. And business management tools you employ for time management, finance management, content management, and human resource management and communication. This is an example of application of digitization to your manufacturing equipment, whatever it can be. It can be a lathe or a mill machine, and a smart mill machine or smart lathe has a controller, a microcontroller attached to it, and a digital readout display, like a computer attached to your lathe and computer attached to your mill machine. So you work like this. A manual worker has to change himself into a computer user, rather working on these he needs to develop ability to work on a digital readouts. So a machine on which this readout is there, and this is there, and the mill machine, which is a digital readout there, and this is how step by step you get into uh, intelligent manufacturing. So this is all what our slides are there, and if there are any discussion or question, I think we can take those up. This is our first workshop on intelligent manufacturing. This is kind of an introductory workshop, and because next time when we are with the Chinese Mechanical Engineering Society and we are holding international workshops, we will know what they are talking about, and we need to uh, be at and uh, need to be aware of the smart systems that are available and make use of them as much as we can. तो जी कोई क्वेश्चन हो आप कम कर सकते हैं, हम डिस्कस कर सकते हैं. बहुत साहब
जी सर.
जी आवाज आ रही है?
जी सर आ रही है.
कोई क्वेश्चन ले लें.
जी अगर किसी का
तो
कोई
फिर
क्वेश्चन है तो आप पूछ सकते हैं.
जी
और काइंडली जिन्होंने अपने क्रेडेंशियल सेंड नहीं किए वो इसी चैट के अंदर सेंड करें.
ठीक है. वो क्या कहते हैं? चले फिर अब इसको हम स्टॉप कर देते हैं.
जी
Let's
सर.
finish our workshop of today and hope we uh, make use of what we have gained today, and look forward to another workshop which will be more detailed and more mm, more to an advanced level. ठीक है. तैमूर आजम साहब, तो कामरान साहब,
माइक अनम्यूट करके आप जो भी क्वेश्चन करना चाहते हैं कर सकते हैं.
Assalamu alaikum, Javed sir.
जी वालेकुम सलाम. जी
This is Farah Amir from Kinate College.
जी फरा, आप क्या कह रही है?
सर मैं पूछना ये चाह रही हूँ कि you are working on the current scenario. Use of data science is basically essential for all of us, especially when we are moving on in industry workability. I would suggest that we must incorporate case studies relating to specific scenarios. अगर हम academics को include करते हैं तो हमारा role ये है कि हम रियल वर्ल्ड सिनेरियोज के ऊपर जो है वो बिल्ट इन सिचुएशंस रादर देन बिल्ट इन सिचुएशंस हम मूव ऑन करें रियल वर्ल्ड सिनेरियोज के ऊपर. तो हमारे पास ऐसी बहुत कम एग्जांपल्स हैं बिकॉज इंडस्ट्रीज आर नॉट शेयरिंग देयर सिचुएशंस और फंक्शंस टू अस. स्पेशली जब हम पढ़ा रहे होते हैं तो हमें इस किस्म के सिनेरियोज जो हैं वो चाहिए, जो कि अगर हम देखें तो डेवलप्ड वर्ल्ड के अंदर इट इज़ वेरी कॉमन. और जितने انڈسٹری اکیڈیمیا لنکیجز ہیں وہ ان کا پرپز ہی یہی ہوتا ہے کہ ایک تو فنکشنل وے کے اندر ہماری جو سپورٹ ہے اکیڈیمکس کی وہ پرابلم سولوشن کی طرف لے کے جائے. سیکنڈلی یہ کہ ہمیں ان پرابلمس کو ایگزیکٹلی جب تک شیئر نہیں کیا جائے گا, ہمارے پاس بہت کم ایسا ڈیٹا ہے, تو کیا ایسی کوئی صورتحال ہے کہ ہمیں بھی کیس اسٹڈیز اسپیسیفک ٹاپکس کے اوپر کیس اسٹڈیز جو ہیں وہ شیئر کی جائیں فرام آل انڈسٹریز, تاکہ ہم ان کو لے کے نہ صرف ان سینیریوز کے اوپر کام کر سکیں بلکہ سولوشنز کے اوپر بھی بات کر سکیں.
جی آپ نے پروفیسر صاحب آپ نے بڑا اچھا پوائنٹ ریز کیا ہے. ایکچولی یہ پہلے ہم یہ نہیں کر سکتے تھے کیونکہ کنیکٹیوٹی نہیں تھی. اب تو ہمارا ایک پلیٹ فارم ہے اینڈ وی آر کنیکٹڈ ٹو ایچ ادر, وی کین ٹاک ٹو ایچ ادر. اور یہ جو ریئل ٹائم سیناریو کی جو کیس ہسٹریز ہوتی ہے, کیس اسٹڈیز ہوتی ہے, یہ بڑی کام آتی ہے. انفیکٹ ڈیٹا سائنس کو استعمال کرتے ہوئے اب بگ ڈیٹا بھی ہمارے پاس وہ فیسلٹیز بھی موجود ہے. اسٹوریج کو, انالیٹکس کو, ہم اس کو استعمال کرتے ہوئے I think you have a point. اور اس کو آرگنائز ہم کر سکتے ہیں. مے بی کیڈٹ کالج میں ہی آپ اس کو آرگنائز کر سکتے ہیں. ہم انفیکٹ ہے انسٹیٹیوشن آف انجینئرس پاکستان, اور انسٹیٹیوشن آف انجینئرس پاکستان میں وی آر کنیکٹڈ ٹو کوائٹ اے نمبر آف انڈسٹریز اینڈ وی ہیو ممبرز, انجینئرس ممبرز. کامران صاحب ہے ہمارے پاس, عبد الستار صاحب ہے, یہ آفتاب صاحب ہے. We have a spectrum of people around who are right there in the industries, اور ہر ایک کو کے پاس اپنے اپنے ایکسپیرینسز ہیں. پہلے زمانے میں یہ تھا کہ وی ور شائی بھی ہوتے تھے کہ ہم ایک دوسرے کو اپنی ایکسپیرینسز بتاتے نہیں تھے, اور کہتے تھے پتہ نہیں کوئی ہمارا ٹریڈ سیکرٹ ہوگا, کر لے گا کیا ہوگا. لیکن وہ جو انڈیویجول جو ایکسپیرینس ہوتا ہے وہ ایک بڑے چھوٹے لیول پہ ہوتا ہے. مگر اگر ایک کلیکٹڈ ایکسپیرینس کا آپ ڈیٹا اکٹھا کریں اور ایک بگ ڈیٹا کو استعمال کریں, جو کہ آج ہم کر سکتے ہیں. وی ہیو دا کیپیبلٹی, وی کین انفیکٹ وی ہیو دا ریسورسز, وی ہیو دا کنیکشن. یہ سب انڈسٹریز جو ہے نا, اب ان کے ساتھ ہم ان کو ایکٹیویٹ کر کے اور اپنے اپنے جو ایکسپیرینسز ہیں جو ہے ان کو شیئر کریں, اور یہ شیئر کرنے کی ایک لائبریری بنا سکتے ہیں. تو مے بی آپ کا کیونکہ فیلڈ ہے اور اکیڈیمکس میں بھی آپ ہیں, اور اکیڈیمک کو انڈسٹریز کے ساتھ جوڑنا بھی ایک کام ہے. So I think this is a very good avenue and we can work together on it. اور یہ مانگے گی بھی. انفیکٹ چائنیز جو ہمارے ساتھ اس کا انٹرسٹ لے رہے ہیں, ان کا یہ بھی ایک پرپز ہے کہ they want to know the real time problems of our industries, rather especially the small to medium size enterprises کی جو problems ہے, تاکہ وہ ریئل ٹائم اس میں کچھ ہماری وہ اسسٹنس کر سکے. تو مے بی میرا خیال میں ایک سرکولر ایشو کرتا ہوں, اور ان سارے جو پروفیشنل انجینئر جو آج کا جو ٹاپک تو مینوفیکچرنگ ہے, تو مینوفیکچرنگ کے ساتھ جو ریلیٹ کر رہے ہیں لوگ, ان کو میں ایک پلیٹ فارم پہ لے کے آتا ہوں. یہ ورکیبل ہے, جو اسپیکٹ آپ نے بتایا ہے یہ ورکیبل ہے, اور انڈیویجول ایکسپیرینسز کو ہم ایک بگ ڈیٹا میں انکارپوریٹ کریں, وہاں اس کو اسٹور کریں, پھر اس کو اینالائز کرنے کے لیے بھی ایک ٹیم چاہیے ہوگی جو کہ سارا وقت یہ اینالائز کرے گی اور کولیبریٹ کرے گی ڈیٹا کو ایک دوسرے کے ساتھ. تو آپ
تھینک یو جاوید صاحب. میری فن ٹیک کی اسپیشلائزیشن ہے. ان اینی وے آئی ول بی اویلیبل. اگر آپ اس قسم کا کوئی بھی پروجیکٹ جو ہے جس میں آپ کو سپورٹ چاہیے, آئی ول بی اویلیبل. ادروائز یہ ہے کہ اور بھی سینیریوز ڈسکس کیے جا سکتے ہیں, کیس اسٹڈی ڈیولپمنٹ پہ بھی بات ہو سکتی ہے. سو پلیز کنٹینیو دس پروسیس I'll be with you, inshallah.
بہت بہت شکریہ آپ کا assistance extend کرنے کا. بلکہ آپ کا آپ کے پاس تو یہ فیسلٹی بھی موجود ہے, ٹیم بھی ہے, اور میں بھی آپ کے ریسرچ جو ورکرز ہیں جو تھیسس وغیرہ کر رہے ہیں ان کو بھی اس میں کر سکتے ہیں. انفیکٹ وی نیڈ ٹو گو فاسٹ, بیکاز جب چائنیز ہمارے ساتھ انٹریکٹ کریں گے تو دے ول بی لوکنگ such stuff of experiences real time, جو مینوفیکچرنگ کے جو ایشوز ہیں اور جیسے کیا پرابلمز وہاں پہ ہوتی ہے اور کیسے وہ ان کو سالو کرتے ہیں, وہ ایکسپیرینسز اگر شیئر کریں پلیٹ فارم کے اوپر, اس کو اینالائز کریں, تو یہ اس میں کائنڈ آف کنیکٹیوٹی انفیکٹ شامل ہے. اور اس میں اس جو کیس اسٹڈیز ہمارے تک آئیں گی ان کو اینالائز کرنا پڑے گا, اس کا اسٹیٹسٹیکل انالیسس کرنا پڑے گا. کر لیتے ہیں, کرتے ہیں. I'll be in touch.
Sure.
جو جی کامران صاحب, یہ اچھا کام ہے. آپ کی آواز نہیں آ رہی, آپ نے میوٹ کیا ہوا ہے. ان میوٹ کریں ذرا اپنے آپ, ان میوٹ کریں.
جی بہت اچھا کام ہے, اگر سب مل کے
اگر
اتفاق سے کریں تو واقعی فائدے مند ہے.
جی, اس کو تو
بہت
نالج
useful ہوگا.
ہمیں اس پہ آنا چاہیے. وائی ناٹ.
جی بالکل صحیح ہے.
ہمیں گزر گیا کہ ہم اپنی کتابیں اپنے پاس ہی رکھتے تھے, کسی کے ساتھ شیئر نہیں تھے کیا کرتے. جی آپ جو ٹیسٹنگ کر رہے ہیں, جو ہائیڈرو پاور پلانٹ کی ٹیسٹنگ کر رہے ہیں, وہاں بھی تو آپ کو کچھ نہ کچھ پرابلم تو آتی ہوگی. اور
کافی ہوتی ہیں, اور اسپیشلی چائنیز کے ساتھ تو بہت زیادہ.
جی آپ تو چائنیز کے ساتھ کام کر رہے ہیں.
جی
چائنیز کے ساتھ کام کرنا اٹسیلف پرابلمٹک ہے.
جی ان کی ورکنگ بہت ڈفرینٹ ہے.
ہم اس کو ہم لے کے چلتے ہیں, یہ تو بڑا اچھا کام ہے. ٹھیک ہے جی. اور جو عابد صاحب,
جی سر.
آپ نے انجوائے کیا آج کے سیشن کو؟
جی سر.
آپ نے آج کا سیشن انجوائے کیا ہے؟
جی سر بالکل کر رہے تھے ہم ساتھ جان کے صاحب کو موبائل میں سب کو جواب بھی دے رہے ہیں, چیٹ آ رہی ہے سب.
جی آپ سن رہے ہیں نا, یہ پروفیسر فرا عامر صاحبہ کیا کہہ رہی ہے؟ وہ کہہ رہی ہے کہ ایکسپیرینسز شیئر کریں, اپنے تک محدود نہ رکھیں.
جی سر ٹھیک ہے, بالکل صحیح ہے.
بس آپ نہیں کرنا ہے یہ کام. پھر
جی سر
میں ابھی آتا ہوں نا آپ کے پاس, تو ہم بیٹھ کے تو یہ ساری جو جتنے سب لوگ ہیں وہ ہمارے کنیکشن میں ہے. ہمارے پاس ان کی واٹس ایپ ہے, ہمارے پاس ان کے میلنگ ایڈریسز ہے, ای میلز ہے. ہم ہر ایک کو ٹچ کریں اور ان کے ورک لیول پہ ان کے جو ریئل ٹائم کیس اسٹڈیز ہیں ان کو کلیکٹ کریں اور ان کو ٹرانسفر کریں پروفیسر صاحبہ کو. ان کے پاس ریسرچ اسٹوڈنٹس ہوتے ہیں, ان کو ان کے پاس تھیسز ہوتے ہیں, وہ ان کا اسٹیٹسٹیکل انالیسس کر کے ان کو ایک ایسی لائبریری کی فارم میں دے جو کہ ایکسیسیبل ہو. کوئی کسی کو کوئی پرابلم, کسی مینوفیکچرنگ کے ریلیٹڈ کوئی پرابلم آئے تو وہ اس کو اس ڈیٹا کو ایکسیس کر سکے.
بالکل سر.
یہ آپ تو چونکہ ہے نا جی, آپ کا کمپیوٹر تو آپ کا فیلڈ ہے اور یہ سارا کام تو آپ کر سکتے ہیں.
جی سر. جی ایسے ہی سر.
جی عابد صاحب آپ کو لگا دیا میں نے اس کام کے اوپر, دیکھ لیں.
جی سر میں حاضر.
ٹھیک ہے رائٹ جی. میرا خیال ہے کہ اب ہم اجازت لیتے ہیں.
سر میری بھی ایک رائے ہے سر.
جی شور.
تو میری یہ رائے ہے کہ یہ اس جو پریزنٹیشن ہے یہ بڑا ویلیویبل پریزنٹیشن تھی. اس کی ریکارڈنگ اور اس کا جو یہ سلائیڈس ہیں یہ شیئر کی جائیں تاکہ ہم اس کو.
جی حماد صاحب آپ ایسا کریں کہ آپ کے پاس ہے نا سارے ای میل ایڈریسز, تو بلکہ میں بھی ڈائریکٹلی بھی کر سکتا ہوں. میں سب کو آپ کو بھیج دوں گا جتنے آپ یہاں پہ موجود ہیں. میں یہ ساری سلائیڈز جو ہے نا آپ کو بھیج دوں گا, کیونکہ ہم نے اس سلائیڈز میں سے ہم نے گزرے ہیں نا, تو کئی ایسپیکٹس ہو سکتا ہے مس ہو گئے ہو. سلائیڈز میں شامل ہے لیکن ہم نے اس کو ڈسکس کی. پھر یہ جو اسٹیپ بائی اسٹیپ پروسیس ہے یہ بڑا یوزفل ہے کہ ایک آرڈنری کنونشنل جو اسمال میڈیم انٹرپرائز موجود ہے اس کو اب یہ انٹیلیجنٹ جو ہمارے پاس گیجٹ ہے انسٹرومنٹس ہے ان کو استعمال کرنے کے لیے آپ کیا کر سکتے ہیں اور کیسے اسٹیپ بائی اسٹیپ اپنی مینوفیکچرنگ کو انٹیلیجنٹ مینوفیکچرنگ میں ٹرانسفارم کر سکتی ہے. اور میں بھیجتا ہوں سب سلائڈ سب کو بھیج دیتا ہوں, نو پرابلم. تھینک یو جی, آپ نے اچھا
جو ابھی والی ہیں اس سے پہلے والی بھی ہیں ساری ہمارے یوٹیوب چینل پہ ہے. آئی پی ہیڈ کوارٹر کا یوٹیوب چینل بنا ہوا ہے.
ہیڈ کوارٹر, جی جی
یہ
ہیڈ
سارے
کوارٹر میں اس کو ہینڈل
لیکچرز
کریں.
چینل پہ موجود ہیں اور یہ والی بھی انشاءاللہ تعالی ہم جلدی اس پہ اپلوڈ کر دیں گے. اور جس کو اس کی پریزنٹیشن چاہیے ہوگی اس کے ساتھ ڈسکرپشن میں لنک لگا دیں گے, وہ کلک کر کے یہ پریزنٹیشن بھی ڈاؤن لوڈ کر سکے گا. اور اس کے علاوہ بھی مطلب دوسرے جو پرانے لیکچرز ہیں ان کی بھی مطلب لیکچرز اگر سننا چاہ رہے ہیں تو وہ بھی یوٹیوب چینل پہ موجود ہیں.
ٹھیک ہے جی. ایک
اس کو کہیں سبسکرائب بھی کر لیں, شیئر بھی کر لیں. سب سے
ہیڈ کوارٹر میں ایک سیل بنا لیں جو کہ اس کو لے کے چلے. ابھی آگے چل کے تو اس کو ریڈی ایکسیسیبل لائبریری کی شکل دینی ہوگی.
جی سر.
یہ آئی پی چینل, آئی پی یوٹیوب چینل کا ایڈریس تو شیئر کر دیں.
جی جی
میں نے
بالکل
آج
سر,
کوشش
بہت
کی
بہت
آئی پی چینل کو کرنے کی, لیکن اوپن نہیں ہوا, پتہ نہیں کیا وجہ. تو اگر اس کا ایڈریس شیئر کر دیں تو ایزی ہو جائے گا ہمارے لیے اوپن کرنا.
حماد صاحب آپ ان کو کامران صاحب کو بھیج دیں, وہ تو بہت آسان ہے.
ہم ابھی اسی چیٹ میں اس کا لنک بھیج رہے ہیں تو یہ سب لوگ جو ہے اس کو جوائن کر لیں, سبسکرائب کر لیں. اس کا نوٹیفکیشن بیل آئیکن پہ وغیرہ کلک کر دیں گے تو ان کو نوٹیفکیشن مل جائے گا. جیسے ہی اپلوڈ ہوگی ویڈیو ان کو نوٹیفکیشن مل جائے گا.
ٹھیک ہے,
اوکے جی, پھر خدا.
اوکے, بہت شکریہ, اللہ حافظ.
اچھا رہا آپ کے ساتھ بات چیت ہوئی اور
ماشاء اللہ بہت اچھی رہی ہے.
اللہ
اللہ خوش رکھے آپ کو, صحت تندرستی دیے رکھے.
اللہ حافظ.
اللہ حافظ.
سب کا بڑا احسان. تھینک یو ویری مچ سر جی.
آجا بلی افسا آجاؤ.
We are waiting for YouTube channel name, please. Thank you very much. ریسیو ہو گیا ہے, ہم اس کو سبسکرائب بھی کر رہے ہیں اور اس کو بیل آئیکن کو بھی دبا رہے ہیں. تھینک یو.